Hello! So here we are looking again at our second example on production planning from the text. And in our last screencast, we tackled part A, which is formulating a profit maximizing linear programming problem. And now in part B, I want to go ahead and solve this problem. And in this version of the screencast, I'm going to use LibreOffice Calc. For those of you who have never heard of LibreOffice Calc before or who have never used it before, essentially LibreOffice Calc is the open source analog of Microsoft Excel. So I will use LibreOffice Calc because that's what I have access to. I use a Linux operating system, both here on my laptop and at work. And so Excel isn't compatible with Linux, so I use LibreOffice. And so LibreOffice Calc, all of the capabilities for our purposes will be exactly the same. If you're solving at home using Excel, all that may change is where the solver is actually located in your menus. And the appearance might look a little different, but all of the same features should be there. So, without further ado, let's go ahead and solve it. And one last note as I solve it. So we did set up our nice problem here. When I set this up in my spreadsheet, I am going to actually try and generalize it a little more. And the main reason for that is to try and get in the habit of writing it in a more general form so that if I want to play what-if scenarios later on, so say do a sensitivity analysis within my spreadsheet, my Excel spreadsheet, then it'll make it a little more easy to do. And having gone through the work to set up the problem, it's a little easier to do so without necessarily going back and rereading the problem in great detail. All right, so in my spreadsheet, let's see. So I'm going to create a column for my product. Okay, so we had 3 products. Okay, and then in terms of profit in dollars, okay, so going back, profit in dollars was 18, 12, and 6. Okay, and you could set this up any way you want, but then let's do number of units. Okay, so the number of units is what we're trying to solve for. Remember, number of units was variables x1, x2, and x3. So when I set this up to solve using Excel or LibreOffice Calc here, the way the solver works is I need to start with an initial guess. Okay, so let's do 1. Product 2, we had to have at least 10, so let's say 1, 10, and 2. I don't know, we'll use 3 different numbers. Okay, and so then with that, I can go ahead and I could have define my objective, which is listed as our profit. Okay, so our total profit, if I spell it right, is equal to the profit per unit times the number of units. Okay, so the profit per unit times the number of units, and we compute this sum over all 3 units. Okay. And now we also need to go back and get our constraints in there. Okay, so let me set up this table. So this was products per hour. Yeah, the number of products we could produce per hour on machine 1 and machine 2. Okay, so let's just set that up as is. So okay, so those times are 3, 5, and 10. And 2 is 6, 4, 12. Okay, then remember these rates are in products per hour. Okay, oh, and let me do, let's just write operating. So the maximum operating time, so this is, let me just write this is in hours. Okay, and actually I don't technically need it, but I'm going to take note of there. And then, okay, so these have units of units per hour. So when I define my constraint, okay, so when we had our constraint equation here, right, which is essentially this would be the time required to make, x1 units of product 1, x2 units of product 2, and x3 units of product 3 on machine 1, which has this max operating time of 24 hours. I'm going to create a cell in which I just compute this left-hand side. Okay, I'm just going to create a cell in which I compute this left-hand side. Well, and I could do this one of two ways, right? I create a cell in which I just define this left-hand side. The other thing I could do is, if I just like 0, okay, I could always subtract 24 from the right-hand side and left-hand side, and so I could bring that over here and make this a minus 24 less than or equal to 0. I could bring this over here and make it a negative 16 less than 0, right? It's, totally up to you. I'm getting old, and so sometimes it's harder for me to remember numbers, as you'll see when I go into Solver. So it's totally up to you. Okay, so let's just bring it over to the left-hand side just to show an example, and we can show the other case as well. Okay, so the total operating time is 24 and 16. Okay, and so then I'm going to define, let's call it constraint 1 and constraint 2, which is just our operating time. Okay, and so that took the form of 1 over the number of units per hour of product 1 on machine 1. Okay, so this then has units of hours per unit, and I'm going to multiply that by the number of units of product 1 plus do the same thing for unit 2. Okay, and the same thing for unit 3. Okay, so it's essentially the required number of hours per unit times the number of units. Okay, and I sum that over all 3 products, so that'll be essentially the total time required to produce those 3 units or those 3 products on machine 1. Okay, and what I do then is, in this case, I'll subtract 24. Okay, because I know that then that has to be less than or equal to 0, right? So I'm just bringing the 24 over. Okay, and we do the same thing for machine 2. Okay, note if I haven't pointed out yet, so I'm trying to enter a formula, right? So I start with an equal sign, right? I just don't type in numbers and refer to cells. I have to use an equal sign because it's a formula. So it's 1 over the rate on machine 2 times number of units of component 1, 1 over the rate of component 2 on machine 2 times the number of units. So getting the rate for product 3 on machine 2 times the number of units of component 3, product 3, and then I'm subtract 16. Okay, and so up here, I think of it, instead of subtracting 24, I'm just going to refer to that cell. Okay, cool. Okay, so then constraint 3. Okay, let's just define it up here. So the min units of component 2 are 10. So constraint 3, okay, so I'm thinking of this one, right? We need at least 10 units of P2. And so again, if I bring this over to the left-hand side, I can write it as x2 minus 10, and that's going to be greater than or equal to 0. Or note, if I want to keep working with less than or equal to, like I have up here, when I brought 24 and 16 over, I could just do 10 minus x2, and that'll be less than or equal to 0. Okay, one or the other. Okay, so let's do, I'm going to do 10 minus x2, so I keep it in that negative form, but again, it's totally a preference up to you. And then our The last set of constraints is just this non-negativity constraint, and I'll show you. We can enter that as a checkbox, or we could rigorously define it. It is totally up to you. Okay, so that gets us everything. So what I'm going to do from here, okay, is I'm just going to click Solver. Okay, so in LibreOffice, it's under Tools, then Solver. Okay, so my target cell, okay, that's my objective function. Okay, and for me that's B6. That's my total profit. I want to optimize that to a maximum. Okay. And then by changing cells, okay, what I'm solving for, my variables are x1, x2, and x3. Okay, so I want to change the number of units of all three products until my profit's maximized. Okay. And then I can list my constraints. So in my case, I'll have constraint 1. Okay. And the way I set it up is that's going to be less than or equal to 0. Constraint 2, okay, is less than or equal to 0. And constraint 3 was also less than or equal to 0. Okay. This is also where I say it's totally up to you how you want to set up your constraints. Right? I could just as well, in here, right, I could have referred to, a cell, right? I could have referred to a cell. I could have typed in a number. It really doesn't matter. It's totally up to you how you want to set the problems up. Okay. And then when it comes to non-negativity, you have two options. All right. One is here, just under Options. You can assume variables are non-negative, right? So you can assume everything's greater than or equal to 0. Okay, and so that's option 1. Or the other way would just be to hard code it. So I can say I'm going to assume that x1 is greater than or equal to 0. Okay, and I've got to scroll down. Remember, x2 greater than or equal to 0, we really don't need to worry about since we're already assuming or have it defined to be greater than or equal to 10. But here I'll define x3 to be greater than or equal to 0. Okay, and so once I have all that entered, I'll click Solve. So it says solving successfully finished. I get a profit, and I get a number of products of 1, 2, and 3. All right, so now I'm going to look back on is in the problem statement had provided a solution, and it is not the same. All right, so my solution is not the same as what's given here. So let's go back and take a look. And so here it is. And so what we find is for component 3, I listed a product of $16 per unit, but in fact that should have been 6. Okay, so updated that. So this is also a nice reason for generalizing what I have to make it clear what all my values are, because there I just found a typo, which might not have been as easy to find if I had just explicitly written it in my objective function. Okay, but now if I go back and try and resolve, everything else is the same. Solve successfully, and I get 43.5. 10 and 75 units, right, which is agreement with what I told you, and then a profit of $1,353, right? Perfect, cool. So we got it. And just one more comment before we stop the video is, again, one nice reason for setting up in this way too is the ability to do what if analyses. So what if component 2 started to net a profit of $16. Okay, so if somehow that magically changed, right, I could just go ahead and I could resolve, right, and now I have a solution for that scenario. Okay, I'm going to turn it back to 12 because I will save this though and post it along with the video online. Okay, so hopefully that helps. And hopefully you can now solve these problems in Excel or LibreOffice. We'll go ahead and solve a couple more this way so you get a feel for it. Okay. Best of luck. Let me know if you have any issues.